you all hear me?
No.
No, Olafar's going to help me. So, all right. Can we have these lights off as well, by chance? Since this is going to be a demonstration of light. Is that possible? Brilliant. Okay, so I'm going to do at least 2 demonstrations. If there's time, I'll do 3. I'll take 15 to 20 minutes is all, and there are very few slides. Okay? And so, but there are just 2 in the first instance, which is here. So here we have 2 identical gray patches. Okay? So what I'm going to do, this is a very well-known illusion. I'm just going to put them in different surrounds. Okay? The one on the left and the one on the right are physically the same. The one on the left is under a light surround, the one on the right is under a dark surround, and then they look different. Okay? It's a well-known illusion called simultaneous brightness contrast. The point of illusions like this is to demonstrate that context is everything when it comes to the colors we see. In fact, context is everything when it comes to all of our perceptions. And this has been well known to artists and philosophers and scientists for centuries. And the deeper question is not whether or not context matters. The interesting question is, why does context matter? Okay? So that's what I'm going to try to demonstrate in the next 10-15 minutes. I'm going to try to explain to you why context determines the colors we see. And the answer to this question begins in the sky. All right. So what we have here, if we go above the atmosphere, space is black and the sun is white. Okay? On the ground, space is blue and the sun is yellow. Okay? And it's been debated for hundreds of years as to why the sky is blue. And basically, there are 2 sides to this debate. One side of the debate is that it's the stuff in the air that causes the sky to be blue. The second half is that it's the air itself. Okay? So this has been debated for many, many years. And what I'm going to demonstrate to you is that it's the air that causes the sky to be blue, not the stuff in the air. Okay? So what we have here is space. Okay? Now what we're going to do, or Olafur, if you wouldn't mind. Olafur is going to add, if you could just add a little bit of milk. Just a couple of drops. You can put it in the cap first. Yeah, brilliant.
Too much?
No, brilliant. Okay? And then with my African spoon here, if you could just mix that around. So what we're going to do is we're adding air into space. Okay? Now, for some of you, you'll see, especially if you're 90 degrees to the angle of incidence of the light, okay, so the light's coming this way, you'll see, can you see that it's turning purple? Yeah? Can you come around this side? You can see it.
Oh, you're right.
Okay. Now, from over here, it's less purple. Okay, so ideally, you all shift right to there. You'd all see it, right? So now notice here that the light that's coming through the air is turning slightly yellow. Okay, so let's add a little bit more milk. So basically, we're now going to recreate the sunset. Okay, the sun is since going to get lower into the air, lower in the atmosphere. It's going to go through more atmosphere. Can you see it's getting more violet? Yeah? And up here, it's getting yellower. Okay? So if we add more, as if the sun is setting, it's going through more atmosphere. In this case, what's happening is the particles in the milk, albumin for instance, are so small that they're scattering only the short wavelengths of light. The long wavelengths of light are filtering through and hitting the screen. Okay? And that's why up there looks yellow and down here looks blue. So if we add even more, eventually up there will start looking red, as if the sun's low in the sky. Okay? Can everyone see that? Now maybe before we do that, for these people. If we go like, okay. Can you see it's purple? So now ultimately, no light will go through. One more time. No light will go through, and basically what we have now is a cloud. Okay, so this is a cloud where all the wavelengths of light are being scattered equally, and so that's why clouds look white. Okay? So brilliant. So that's the sky in the bottle. So this is an experiment that Roscoe did. There'll be a couple more things as well. This is an experiment that Roscoe did, not Rothko, Roscoe, in the mid-1800s to address the question of why the sky is blue. And the answer to the question is because of the air. Now, what I want to do is to ask, why does this matter in terms of our perception of color? What it demonstrates is that illumination of the world is not just white light. It's blue, it's yellow, it's green, it's orange. Okay? If you're under the canopy of a forest, most of the illumination is green. So why does this matter when it comes to generating our perceptions of the world? Well, we have to think about what color is for. And what color is for distinguishing between surfaces in our world. But as Berkeley tells us, we have no direct access to the surfaces in the world other than through the light that falls onto our eye. Okay? Because our illumination is constantly variable, it means that the light that falls onto our eye is meaningless. And I'll show you what I mean by that. So, would you mind? I want to move this out of the way. I'm going to put these two up here. Okay. Okay, so what do we have? We have green surfaces, okay? And we have purple surfaces. Now, the aim of color vision is, let's say, to distinguish between these different objects. Let's pretend that they're reflecting light instead of transmitting light. Okay? So now, imagine that at the moment they're under white light, which is why we can distinguish the green surfaces from the purple surfaces. The light that's falling onto your eye from the surfaces is different. Now, Olafur, if you wouldn't mind imagine that this surfaces on the left side are placed under green illumination. So if you just slide that right over there. Okay? Now also imagine that the green surfaces on the right side are under purple light. Okay? So I want you to focus on these center 9 surfaces and these center 9 surfaces. Okay? Now, as far as the reality of the situation, these are different surfaces under different lights. But as far as your eyes are concerned, the information coming from these two different surfaces is exactly the same. Okay? So in a sense, we have the green surfaces under blue skylight, you could say, and we have blue surfaces under yellow sunlight. This is the fundamental problem that all of our brains have evolved to solve. The ambiguity, the meaninglessness of the information that falls onto your eye, because that information conflates multiple things about the world. Okay? So how does the brain solve this problem? And the way it solves this problem is by generating what it sees according to its past interactions with the world. It takes the patterns of light that fall into the eye, and it generates perceptions according to what that information meant for behavior in the past. Okay? And what I want to do is I want to show you how quickly we can adapt and generate new realities of our physical world. And let's see, maybe if I can plug that into, no, I'll move that down here. Now, I have to put on some glasses. That switches on. Okay, brilliant. So what I'm going to do is I'm going to ask Olafur, do you mind coming around here and take that ball, stand here in front of the screen, and the object is to hit, the object is to hit this spot, this red spot with this ball, okay? Underhand, so we don't, or overhead. But maybe underhand, okay? We just want to make sure that you can hit the spot. Okay, brilliant. Now what I want him to do is to put these goggles on, okay? Okay, and to just turn around so everyone's so, right? Gorgeous, right? Okay, so we know that he can hit the spot with the ball, okay? Now he's going to try to hit the spot with the ball. So what's happening? What he's wearing are prismatic glasses. Now we heard about these glasses a couple of talks ago, okay? Now, he's getting feedback that what he's doing is wrong, in a sense. The prism glasses have shifted his visual world about 20 degrees or so to the right, which is why he's throwing to the right. Because as far as he's concerned, his reality is that the object's over there, okay? But he's learning that this is not right, and so slowly, after time, through experience, he's compensating. He's trying to hit the target. Okay? Almost. You got it? Close. It's almost there. Okay? So he's learning a new reality. He's redefining normality. Brilliant. Let's keep going. Okay? Make sure he learns this new reality. Brilliant. A couple more times, right? Be convinced that these aren't just luck, right? Oh. One more time. Now what I want him to do, take the goggles off, and hit the target. Try it again. Over to the left. Now we have to make sure he goes back to normal, so we'll see a lawsuit coming.
Okay.
We could be here. Oh, one more time, I'm sure you'll. Brilliant. Okay. Thank you very much. Okay, so what happened there? His brain redefined normality in terms of space, and this demonstrates the fundamental relationship between our physical body and our perception of the world. Okay? And it demonstrates how quickly, through experience, we can come to perceive and conceive a new sense of reality. So let me, potentially lastly, go back to this. So what does this mean for perceptions of color? Okay. Remember, we have two very different realities here. We have purple surfaces under a green light and green surfaces under a purple light. As far as your brain is concerned, the information is exactly the same. Okay? But we don't generate perceptions of just the patterns that fall onto our eye. We generate perceptions according to what this information meant. So now, if we take off the masks and reveal the rest of the scene, what you see here are green surfaces, yes, 25 green surfaces, including the 9 in the middle. And what you see there are purple surfaces, 25 of them, including the 9 in the middle. But you know that these are physically the same, right? As far as your eye is concerned, they are identical, but they mean different things, okay? So you take into account context, but not just context in of itself, but what that context meant in past experience, okay? Everyone believe it, yeah? Okay. So, finally, if we go back to this, I don't think it matters that it's on an angle. I think you can still see it. This is the illusion that we saw in the very beginning. These two surfaces are physically the same, one in a dark surround, one in a light surround. So is it just the darkness of the surround that causes illusion and the lightness of the surround? The answer is no. There are the same illusions again, two tiles in a dark surround and a light surround, okay? And the same two tiles in a dark surround and a light surround, okay? The same illusion. Now what I'm going to do is I'm going to reveal the rest of the scene on both sides and watch what happens to your perception of those tiles. This one and this one now look very different. This one looks much lighter than that one, even more so than it did before. These two, however, look nearly the same. And yet this is still on a dark surround, and that's still on a light surround. And similarly, this is still on a dark surround, and that's still on a light surround. But what's being presented to you is information that is consistent with your experience of two objects under different lights, whereas in this case, it's two objects under the same light. If these are objects under the same light, then they must be the same thing, so you see them as being similar. Here, the information is consistent with two objects, different objects under different lights, and so you see them as being different. Okay? Another example is those two. We have a brown tile on the top, an orange tile on the side, and they are physically the same, as shown here. Those two surfaces are the same. The one on the top is physically the same as the one on the bottom. Okay? And this is the last one. We have 4 gray tiles on that side, 7 on that side. Just follow your perception of this one. I'm just going to reveal the rest of the scenes. And notice how your perception changes to blue, though the tile is still gray. Okay? So, what's true of color is also true of motion. Would you mind? Brilliant. So for me, a little bit higher. Okay, so you can either look at the diamond, or you can look at the shadowed diamond. Okay? What I'm going to do is I'm just going to rotate it. Okay? It's more astounding if you look at this, because this is the reality. Which direction is it rotating? This way, right? Keep watching it. Blink every once in a while. Look around. Tell me what happens to your perception. Does it suddenly start flipping the other way? Anyone? Yes? Now blink, and every time you blink, sometimes it will go this way, then that way, right? In fact, it's doing it from here. Question is, which direction is it actually rotating? Anyone? How do you know? It could be spinning this way or that way. It depends, in fact, on where in the diamond you look. Okay? Thanks. So that's more or less the end of my little thing. And just the concluding point is that our perceptions and conceptions of the world reflect our past interactions with our physical, social, and cultural world. Okay? And there are no absolutes when it comes to perception. Perceptions are necessarily relative to an ever-changing normal because the sensory information is meaningless. So the only way we can survive is by generating perceptions of behavior according to what information meant. So we're constantly constructing meaning. Okay? So there you go. Thank you very much.